right, group. So, logs and exponentials.
Oh, yeah.
We've already been talking about the exponentials. Okay, now we're going to transition to logs. The logarithmic function is actually the inverse of an exponential. So they work hand in hand, and we're going to kind of we're going to take them from one form to the other today. That's kind of what today looks like. So the log function has a base of b, where b has to be greater than 0, meaning b has to be a positive number. You can't have a negative base. And then it also cannot be a base of 1. So the base of the log could be anything that's positive and not 1. And it's noted by this. So this is how we write that. Okay, log base b. Okay, and we define it by the equation y equals log base b of x. So that's what a whole logarithmic function would look like. Okay, and then if we want to take that and write it as an exponential, it's b to the y equals x. B to the y equals x. So I'm going to kind of show you how I get from a log to an exponential. Okay, if we look at the base, we always start with the base. I go to the y, and then I come back around to x. So b to the y equals x. So that's how you go from the log to the exponential. Okay, and then we're going to go from exponential to log. We're going to practice those, and you'll get better at those as we go throughout the day. Any questions for me on that? All right, so when we have the regular log, log, okay, with a base of 10, okay, so log base 10, does anybody remember what that's called, what kind of log that's called? Log base 10. Starts with the C. It's called the common log. Okay, we call it the common log. It has a base of 10. Okay, now what about if it has a base of e and you use ln? Do you remember the difference between the common log and then using ln with a base of e, what that's called?
Inverse log.
It's not inverse log. It's called the natural log. Natural log. Okay, and it has a base of e. So your natural log is ln, common log is log base 10. Okay. So when we look here, if you look at our original log function, to get to the exponential version, we do our b to the y equals x. So by equals x. Here, we assume the base e because it's not written. Okay, so we do e to the y equals x. E to the y equals x. Now, we can also go from exponential to log, and I don't want to confuse you here, so we'll do that separately. We good on that? Okay. All right, so let's jump in here. We're going to rewrite this exponential as a logarithm. Okay, so do we see any e's here? Okay, there's no e's, so you know we're going to have log. Okay, and then we always start with the base. So our base is 7. Okay, so it's log base 7 of 343 equals 3. So you start at the base, go around the equal sign, and back to the exponent. Okay, so log base 7 of 343 equals 3. So another way of thinking about it, this may help some of you, is that the exponent, that 3, is on the other side of the equal sign. Okay? And that will always happen. So here, let's do the same thing. So we have log base A of 1.9 equals 5. So same thing. Start at the base, go around the equal sign, back to your exponent. Keep in mind that exponent is always on the other side of your equal sign. Okay, now what do you notice about C? Yeah, we have E there. Okay, so the process is the same, but now we're going to use ln, which is the natural log. So we start at base e, around the equal sign, back to the exponent. So natural log, base e, technically you wouldn't have to write that if you didn't want to, of 14 equals x. Okay, part D, we're going to do the natural log. Okay, e of 2 equals x. So natural log base e of 2 equals x. Yep.
Do you have to draw fancy L or can I just do regular?
Oh, no, you can just do regular L. I just do it so that you guys don't think it's a 1.
Okay.
Yeah, you're fine. Yep, however you want to write your L is totally okay. All right, do we have any questions on that? All right, so that's exponent or exponent form to log. Now we're going to do log to exponent. Okay, so this just kind of explains e. Okay, e is this number here. We call it the natural log because e, the number e, which is 2.71828, it's kind of like pi, but e shows up so many times in science and math and like actual like world type math problems. It's really kind of a cool number, and that's why they call it the natural log, because it's naturally occurring. We see it everywhere. Okay. All right, let's go to our logs. So we always start at the base. Okay, so log base 3, -2, back around to the 1/9. So it'll be 3 to the -2 equals 1/9. Now, here's what's really cool about these. Okay, I can check them in my calculator. So if I go 3 to the -2, it gives me that. If I change it to a fraction, it's 1/9. So once you rewrite it, you can actually put it in your calculator and make sure that it's true. Okay, some of them you won't be able to, but most of them you will. Okay, so for example, B, this one would be kind of tough to check, but as long as you have the process, you're fine. So start at your base, around the equal sign, and back. So 10 to the x equals 26. You doing okay? Okay. All right, down here, now we have the natural log. What's the base of a natural log? E. Okay, so we're going to go ahead and write e in there because it's not written. Okay, so we start at that base e, we go around. So e to the x equals 4. Same thing on D. We have to have that base e when we go around. E to the 2x equals 5. Okay, what did you notice about the number that's not with the log that's on the other side of the equal sign? Huh? It's the exponent. Well, when we just wrote the exponents into logs, wasn't it always the exponent? Yes. Okay, so that's something you can always check to make sure you're doing it right too. Okay. Questions on rewriting? Okay. So now we're just going to do some simple solving, a little bit of solving. Tomorrow will be our bigger day of solving, but I just kind of want to get our feet wet here with this. Okay. If we look up here, it says evaluate the log expression and find the exact value. You're going to be solving for the variable. Okay, so here we're going to be solving for a variable, but there isn't one. That's where we have a problem to start. But when we look at the log function, okay, we know that we always have an equal sign. So we're going to put equals x. We're going to have to solve for the exponent here. Okay, so each of these you can write equals x. Okay, the first thing we do, looking at this, we're like, who knows? Okay, we don't really know. But we have worked with exponents enough to know if it's an exponential form, we can solve it. Okay, so we're going to rewrite this. 2 to the x equals 16. Now, what power of 2 will give you 16. 2 to the 2 times 2 is 4. 4 times 2 is 8. Times 2 is 16. So that would be 4. So 2 to the 4th is the same thing as 16. Therefore, x equals 4. Yes.
So we don't have to write an ln or log.
No, it was already in a log. We transferred it to exponent, the exponent form, and then solved it.
So you still have to write it.
Nope, you're good. Yeah. Okay, so here, 3 to the x equals 1 over 27. So I just rewrote that. 3 to the x equals 1 over 27. This is a little difficult sometimes to think about. So I'm going to simplify it really quickly, okay? 3 to the what power is 27? 3 to the 3rd. Okay, but what's different here? What's different? We want it to be 1 over 27. Does anybody remember what we can do to an exponent to move it to a different location? What'd you say? Okay, I mean technically yes, but to flip those, what do we do to the exponent? Make it negative. Okay, so if an exponent's negative, we need to transition it to a different location. So in this case, if it's in the numerator and we want it to be in the denominator, we just make the exponent negative. So in this case, when we rewrite this, 3 to the negative 3rd is 1 over 27. Okay, I'm going to solve that and show you what I mean. So what I mean by this, if I take 3 to the negative 3rd, it's like 1 over 3 to the 3rd, because when I move it to the denominator, the exponent becomes positive. Then I can evaluate that, which is 1 over 27. Okay, it's going to take you a little bit of time, but you'll catch on here. So in this case, okay, what was my x? What was x? Negative 3. Okay, part C, same deal. Okay, this has a base of 2. So 2 to the x equals the 4th root of 2. Right, now, do you remember, if I have the square root of, okay, that would be like 2, okay, square root of x, does anybody remember how I can write that instead of a root, write it with a power? Square root is the same thing as x to the number 1/2. So if I have the 3rd root of x, that's like x to the 1/3. So if I have the 4th root of 2, 2 to the 1/4. So we rewrite that. We just learned when we did exponent rules, if they have the same base, what can I do with their exponents? It's simple. Don't think about it too much. Not add them. So I'm equal to each other. Okay? So if I have the same base, get rid of the bases. X is 1/4. Okay, the last one is just a calculator problem. Okay, you just have to find which power is going to make this true. So if we rewrite this, okay, it would be 3 to the x equals 234. So we need to figure out what power of x on 3 will give us 234. Yeah, so we'll do 3. I'll do the first one, 5.455. Oh, 400. Nope. Oh, that's not what I wanted. to the, oh lordy be. Right. There we go. Yep, 234. Okay, I could check the rest of them, but we know 4.9 is close. These are not going to be close. So B would be your answer on that. Okay, what questions do you have? Okay, if you flip it over, the first section is changing from, it says rewrite the equation in exponential form. So you're going from a log to exponent. Then 7 through 14, you're going from exponent to log form. And then 15 through 29, those are some solving like we have up here. Some of these get a little tough. Okay, I'll tell you, some of them get a little tough because there's some fractions in there. Okay, but just do your best on those. I have all the answers up here for you so you can check yourself as you go. Okay? So hopefully pretty straightforward day there. Tomorrow, we're going to do just some, a little bit more intense solving. Okay, we're going to use some different rules that we haven't talked about yet. You have seen them in Algebra 2, but we're just going to kind of bring it back up. Okay? Questions for me? Awesome.